Hello everyone. Sit back and prepare to enjoy this talk from Devfest Montreal.
Good afternoon, everyone. That's time where we're restarting the machine, restarting to talk about different technological topics. So this afternoon, what I'm bringing here, I'm bringing a topic about AI, obviously. We're in 2025. What's a talk without AI in a talk? So I think it's beginning of the year, one of my colleagues told me, hey, Yan, we should do a presentation about AI and about reverse engineering. So, oh, that's great. That's a good idea. And started to work on that and say, okay, we're going to try to get on different conference and we're going to try to present those things. Great. So we started to work on that. And along the way, he resigned. So now I'm alone presenting that. So he moved to another organization, but still I decided to continue to make some tests, some things around here, the reverse engineering and the AI. And the question that I wanted to respond here is, first, I'm not a reverse engineer at all. That's not my job. This is not what I'm doing. But it's always interesting to understand how those things are working. And sometimes I'm coming from a background where when I was younger, I wanted to play some video games and I needed some cracks. And I said, oh, how those guys were doing those things. So really from that time, I said, how it's working. So I decided to try things with AI to try to educate myself. So who am I? I'm a guy who's playing a lot with Nano Banana. Obviously, I didn't met him. Otani is not taking time with me, not especially at this time of the year. But I'm really passionate about travel, about sports, about security, about AI, and many, many different other things. I'm also a Googler. So working at Google, my role at Google, cloud security architect. So I work with a few of you already, some familiar faces here. So like I said, I'm not a reverse engineer, but I'm really curious about how those things are working. So that's why I started that small journey. So that's the question. Can the AI do reverse engineering? And the answer, sorry, I gave you already the end of the presentation, but the answer is yes. It's possible to use AI to do reverse engineering, but the most interesting portion that I found out is the educational aspect of it. How the AI will help you to understand what's going on, what's the next step, what you should do. I don't know if some of you already opened a binary or an executable. Yeah, okay, a couple of people. So you know that sometimes you open those things, it's a bit scary. So the first time you're doing that, you say, I'm not going to be able to understand how those things are working, how assembly is working. It's different level in the stack. So do I really want to spend time learning those things? But AI helped me really to scale that portion. So when you're looking at those things here, obviously, it's really intimidating. We have absolutely no clue what is that, what's going on, except if you're really good in assembly and you can understand that just by reading it out. And when you start doing reverse engineering, this is where you start to understand that there's a lot of different architecture in computer science. So if you try to do something on x86 versus ARM, it's very different. So you need to pass different command. You need to understand really how the architecture of the system is working to be able to find what you're looking for in the system. And I will tell you, it's not only to do some cracks for video games or things like that, or to bypass security protection. There's really innovation that you can do with reverse engineering, and sometimes it's really to extend life of different products, but I will come back on those things. So here it's really, really important, specifically when we're talking about security. So security engineer or reverse engineer, found that portion very interesting because this is the location where we can find how the system is working, how the system try to exfiltrate information, how things happen behind the scenes. So it's really important for not everyone, but for a few people to understand those portions. That's easy. That's easy. Just a simple hello world here. So it's the same code. I just copy paste the code in Gemini and just ask Gemini, explain me those things in Python. So you just reverse that, convert the code from assembly to Python to give me an explanation. That's very, very simple. everyone can do that. You can just, even you can do the other way around. You can just ask Gemini, generate some code in assembly to say hello world, and after you can translate that. So you can play both way. And to be honest, this is what I did. I just asked to create this code in assembly before doing it the other way around. But no worries, we're not going to go too deep on those things. Yes, we are going to open a binary. We're going to look how it works, how we can use AI to understand what's going on. And if we're lucky enough, maybe we're going to find a vulnerability somewhere in the things. But because it's a presentation and a demo, you know that I already planted something. So here. So I said earlier that reverse engineering can be used in different places in life. For sure, innovation and improvement is really a location in organization that it can be really important to have, to understand how things are working, making sure that you're doing something similar, or really understand the product. So understand behind the scene, really key. The interconnection between different systems. Sometimes we're having legacy systems in organization, very old systems. We have no clue. The guy who built that died a long time ago, and now we're stuck with this thing's working. We need to go back, revert the information. I said 4 or 5 years ago, I was working on a big project to revert a lot of code from a big mainframe and modernize all those things. At the time, AI was not efficient enough to do those things. Now, a big portion of it can be done with AI. It can really translate the code. Need a lot of tests. Obviously, it's not 100% guaranteed that everything will work, but understand how it works. Make sure that you can connect things together. Sometimes protocols are not working. Understand how the receiving protocol or the emitting protocol is working can be also a good place here to work with. Maintenance and obsolescence. To be honest, when I started that, this is exactly what I had in mind, to look at that portion, because I'm not that old, but I'm starting to think about my retirement, and I say what I will do. And my retirement, I feel like I will try to fix German machine that they are in industrial location that no one have any way how those things work because the company closed out. I feel like I will try to help them to interconnect, create some connectors to retrieve data from those machines. One of my uncle is doing some invention, so I'm already having a couple connection in that area, but it's really, really interesting when you start getting information there. And the other place where we're not seeing this kind of innovation being done every day, but it's there in our real life. For example, police car. Police car are a standard car, but they did a lot of reverse engineering on those, and they created the police pack to install the police pack. So better engine, better brakes, better transmission, better everything. But it's all come up from a new chip that they're adding in the car. So they're taking the information from the manufacturer, they're looking at it, do reverse engineering to realize that, oh, it's the same engine, that the capability of the other one. But if you unlock the message that you're sending to the engine, you can get additional capability. The same way that we're overclocking our computer, you can do that with car. It's all with chips. If you understand those chips, you can tweak those chips. There's a limit where you're going to blow up your car, but it's really the way they're doing those things in organization that they're building planes. There's a lot of reverse engineering also being done in that portion. So it's not only few people in their basement trying to find vulnerabilities, but it's obviously, when you're in security, one big topic, finding vulnerabilities, finding how those things are working. And sometimes that's one reason not a lot of people are doing those things. And sometimes we're having latent code in a product that we're using for a long time, that one day we're receiving, oh, a 0-day just got found in that product because no one really reverse engineered that portion of the code. I got the chance through my multiple years in different organizations to do some small reverse engineering, to inject our logo in few product where we're not supposed to, or to gather information that we're not exactly supposed to do. But I have done those things in the past to have a better understanding. But it's really the big things here with reverse engineering is you need to be curious. You need to be curious and going in an area that you have absolutely no clue, or just being amazed about something. So if you're the type of person that loves to do some puzzles, that's a good place to start. So when we're doing reverse engineering, specifically the one in software, we're having different types, two big categories, and we can argue about those, but two big categories, the static, so the first one on the table, and the last one, the dynamic analysis. So the static analysis, this is what I'm going to do today. So I'm just taking code, and I'm going to make an analysis on it and understand the code. So I will look at the functions, how those things are working, how the code is attached together. So I'm not going to look necessarily about how the memory is working, how the process is working in the machine. That portion is really more the dynamic analysis that we're using to see how the calls really are working live for real in the systems. In the middle here, the disassembly and the compilation, sometimes they're complex to make the difference here, but disassembly is really when we're taking the machine code and we're bringing that to, for example, binary, and we're going to bring that in assembly, so machine language. Even the machine language, this is what we've seen at the beginning, it's not that easy to read, and that's why we're having another layer, the decompilation, where we're going to take this assembly and we're going to move that in another layer of the stack. So we're going to transform that in C, in Python, in another language. Even Python is even higher in the stack. But that's really how we're going to work generally to understand those things. If you're doing all those things manually, it takes time, a lot of time. So that's why sometimes you're not spending too much time on those things, except if it's your job or really your passion. But there's good tools that are available. Gitara, for example, IDA, it's another one. Radari 2, also it's a good one. Today I'm going to use Radari 2, and the reason for that, I was on the lake house when I started to work on those things and with a very limited connection. So I decided to use the smallest package I found, which was just a small Unix package, and I just stick on that one to continue. So I'm using this one, so that's why it's not UI based, it's going to be command line based to see how this package is working. So here I already mentioned I will use Radari 2 on that. It's really an open source tool that you can use, but I will use two different package to two different plugins. So DK is really the decompilation AI. That I will inject in the system to have a little bit help of AI, and R2 AI is really the Radar 2 AI plugin, or this one I can just ask different questions, just basic questions, nothing really to decompile, but to help me to understand the package. And to challenge myself, I say, okay, I need a binary to open, and if I just create a binary and I open it, it's just a bit boring. So it's like when you're a kid and you're doing your own puzzles and you're rebuilding it. There's no big challenge here. So I just went on Cracking Challenge website. So I picked rootme.org. There's a lot of challenges on that website, and I focus on the Crack Me one. I said, okay, let's look how it works. I told you I work at Google. So I said, if I'm only talking about Gemini, it's going to make sense. But I want also to look at how other people are going to behave in that race. So I look also at what Claude can offer and what ChatGPT can offer on that end. So what I did initially, so when I started the process, I just opened up the binary and I was doing a manual copy. So I was looking at the main function, I was just doing copy paste inside Gemini, Claude, ChatGPT. I had all of them and I was sending exactly the same prompt and I sent the command. All of them were working and all of them were asking me different questions. Oh, I need to have more information or for X or other portion of the code. So I was just copy pasting. Obviously, it was not really efficient. But after I said, okay, I need to optimize that process a bit. And this is when I found out about the DK and R2 plugin, where I just installed those plugins, and now I'm just asking those plugins to do the copy paste and the exchange with the LLM. So really to speed up everything. So it's almost the same process, but I'm not doing the copy paste. The model is asking me still to type the command. I still need to type the command, and he's just reading about the results and giving me insights, but still it's possible. But it's not the most efficient way to do it. The most efficient way to do it is let's go here. I will come back. It's really to use an MCP server. When you use an MCP server and you attach for example, your code with Radar 2 and what you want, you're just asking your LLM, and your LLM will start doing all the job for you. It will almost answer himself. It will run the command he needs. It will just go down and drill down inside the code to get all the information. Way more efficient, a little bit more work to put in place. But even if I'm running those things here live, it's not that great. You're just seeing a lot of movement and nothing really interesting, but really efficient to work. So what I did, I told you I use R2AI. So I just put here a couple of examples, specifically after I think presentation will be available. So just if you want to play with those things, there's a lot of possible comment that we can use with that one. R2AI is interesting, but the most interesting one for me is really Decay, because Decay is helping me to find problem, explaining me functions, making sure that I can go deeper and deeper in the stack. And at some point, for sure, the LLM start to not being sure exactly about what's going on. But let me show you how that thing is working. You're having the full screen here. Yes, it's great. So here, what I'm going to do, I'm just going to open a standard one here. I did a lot of clear before. Okay, great. So I already have a binary that I found out on RootMe. I just rename it. So what I'm doing here, I'm going to do the manual process just for you to see how it works, and after I'm going to run it with AI. So here I'm just going to start those things. I know that I have a couple of commands to run because I've run that many times. So I'm just sending a couple of commands to find the entry points here. After I know that I'm having to check that, okay, I found 24 entry point. Here I'm going to list all the entry point, the 24 one. And generally when you're doing reverse engineering, you're looking for an entry point. Where can I enter inside the project, inside the program? So generally the main is the one that we're looking for. So I'm just entering the main, and I'm now inside the main. Let's print what we're having. Oh, cool. Memory, a lot of things. Not necessarily easy to read, not too big, but not that cool. I can change that code in C, for example. So maybe it's a little bit easier to read, but not exactly what we're looking for. So it's not that easy because we need to understand, we need to go deeper, but very quickly we can just navigate inside a project. This one is a very simple one. So when you're running that, quickly you find the thing. So I've been able to solve that challenge without anything, without any AI, but the fun is just to see is the AI will be able to do it faster than me. And so if I'm going here, I'm just gonna, oh, I think I already copied it. I will just exit to make sure that everything is resetted. Great. So now copy, paste here. Great. So now I will ask my plugin to do that. So Decay, help me figure this challenge. And now we can see that the thinking is starting. So automatically you say, oh, can you list me all the function? So imagine if you have never done that, you don't know what command to run. So here is just telling me, can you run me the AFLC command to list all the entry points? So yeah, cool. AFLC. He's still thinking, looking, he says, oh, I found nothing. When you found nothing is because you need to list them first. So say, hey, you forgot to list those. So I say, okay, I know. And he told me to do AAA. So cool, doing it again. And it will think, it's going back. So, okay, now you run it. Can you give me back the information? So sending it again. So now, oh, 24 entry point. What are those? Exactly the same thing that I've done before. The AFL, sorry, looking at those things. It will find by himself the entry point here. So he's telling me I found the entry point is the main. Can you help me with that? So can you print that for me? So we'll say, okay, PDC at main. And he's still thinking about it. He's looking at the code now. He's making an analysis of, is it working? What is that? Cool. Here's the breakdown. He's giving me all the information about what he found in that function. But look, to solve this challenge, you need to provide 1, 2, 3, 4, 5, 6, 7, 8, 9 as the password prompt. Super easy, super easy. But had absolutely nothing to do. So the the LLM find out for me this information. This example was really easy because everything was in the main function. So I didn't have to go on and jump to function because that's a way you can do. You can just go to different function, have different algorithms, and you need to understand what's going on. So if I said, I want to explain me that that specific function. Let's take the same one. So here it's an option indicate that you can ask him, explain me this function if you don't know or you didn't find exactly what you want. So here is still sending the information to Decay and will give me a feedback. You can do it with the information about what it is. Maybe. Okay, great. So this function serves as the main entry point, running in a C runtime environment. So very, very simple. But if you move in different environment, which is also something that I've done after, we'll show you after, but it can start to be a little bit more complex. The cool thing we can do with that, because sometimes we can solve the challenge that way, or if we're doing some verification of a code, doesn't mean that we want to crack anything. Maybe we just want to find, is there any problem with that code? Is there some buffer overflow or things like that? What you can do, you can ask the model to do some vulnerability scan of the code, and he's going to do it for you. So it will look at all the instructions, how you're managing the memory, how things are working. Even it will run some tests for you. It will try to do some buffer overflow, and it will try to see, is my test are working or not? So when you're running that on specific binary, I'm not running that for fun, so we're going to have something, hopefully. But we're able really to understand what's going on, and they're giving you also explanation. So it's not just that you find the solution, you find the problem, is giving you information about it. So you can learn from the process. Because just doing it for doing it and not really learning from the process, for me, was not really making a lot of sense. When I'm reading the information, it's, oh, okay, this is why it's working that way. Because when we have a simple challenge like this one, it's great, working perfectly. When it's a bit more complex and you need to have your own reflection, this is where understanding and learning from the model is really interesting. And around me, I'm lucky, I'm at Google, so I'm having a lot of very good reverse engineer at the office, so I can learn from them. But recently, when I started to work on those things, they looked at the code and they said, oh, really interesting, really interesting. Okay, let's see what we found here. Okay, here, what did they found? It's not returning me fun stuff. Not cool, Gemini. Let's see, did I copy the right thing? Yes, it's a big V. Okay, Gemini didn't want to cooperate on the live demo. But anyway, the results in general is the fact that in that one, we're having a couple of problems. So it just returned that, yes, there's a buffer overflow. It tests with everything's been able to overwrite memory portion of the code. I will rerun it, and I will pass back here to see. I will let it run. Let's go back here. Great. So when we're using the MCP approach, and the reason why I just want to take a couple of minutes to talk about MCP is because MCP has been released 1 year ago. Not so long ago, and sometimes I feel like because of my job I'm living in the future, so I said I need to just come back and just making sure that everyone worked with MCP, or at least I've seen or understand that term of what is MCP. So before MCP, so MCP has been developed by Entropic, and here this is how we were doing things before. Let me just. So before we were attaching different API call directly to the LLM, which was good, but not necessarily that efficient because you had to open different connection. The MCP server is giving us the opportunities like a USB hub. So you have your USB hub that it's connected on your LLM, and on the other side, you're having all the connectors on different tools. A lot of organizations are releasing MCP server now, and you can connect on those MCP server. The best way to understand how an MCP server is working is by building one. It's not that really complex these days with vibe coding. You can vibe code your MCP server very quickly, and in a couple of hours, you will have something who's working. Yeah. Yeah, yes, fast MCP. Yeah, exactly. It's really the way to go. It's very, very fast, and you can really have something quick to go. When you build that, and I think I have an example here, it's just to have a visual representation about what is MCP. You will find a lot of repository online about different MCP servers available for everything and nothing. Sometimes you have 10 different ones for the same thing, so you need to look at the function they are offering. But now I'm not managing anymore my Google Drive, my personal Google Drive, or many things that I had to do. I'm not managing those things. Okay, copy those files, do this, do that, and it's just managing all the drive for me. You can even have an MCP connected on your own laptop to handle your file on your laptop. For example, your Windows laptop, you can handle that with the LLM, and it will do a lot of tasks for you on your computer. So that's important to know that, because it's really a set of tools that you are going to provide to your LLM to go faster, to do more things, but be careful. Obviously, those things can turn out to be ugly pretty quick. So if you need to organize those things well and making sure that you provide the right access to those things. So if you give access to your email, you may have sensitive information in your email, things like that. So just be careful with this kind of tools. Really powerful, but we need to just have a good way of doing it. So when I did the test, I picked really 3 different challenges. So I pick a simple one so we can see the level. So the first one at the top is really a green one, not very difficult. The one at yellow, and the other one orange. So just going in the stack, I use Sonnet 4 from Claude. I use Gemini 2.5 Pro, 2.5 Flash. GPT, when I tested it, was the 4 version, and I tried the GPT reverse malware one just to see, because there's an offering in GPT that you can pick one that is already pre-built to do reverse malware. Why not? In fact, why not? So I did some tests. I ran some tests on those things. So you can see here, it's what my test looked like when I did those things, which is copy pasting everything back then. And here are the results. I'm happy and not really happy at the same time. Initially, on the first pass, Gemini failed the first time that I've done this presentation. So every time it was failing, and I was going to present the day after, everything was failing, and I decided to present it that way. So the first time I presented the results, I just explained to everyone that Gemini failed to all my tests, and I was representing Google on stage. It was not the greatest moment of my life, but at some point, that's the truth. So, and I decided I don't want to hide that results. It's a real results, but what can I do about that? And very quickly, right after, even when I was on stage, I was still thinking about the result. I said, oh my God, there's red on side of Gemini. And the problem is I was just sending information without adding some system instructions. So the context was not right. So I just realized that I was not sending enough information in the context to be able to do the right job. This is what I've done after. I just ran that with better context, and it was creating, for example, just inside, I was using Gemini.com at the time. I just created a gem with good system instruction, and when I reran all the tests, it was able to do it. So I said, okay, it's interesting, and that's exactly how GPT reverse malware is working. It's still GPT. But it's GPT plus system instruction that is saying that, oh, you're an expert in reverse malware. You know this, you know that, and now is behaving the right way. So when I ran the test, you can see that, for example, the first test, the simple one, all model did it the right way the first time. Even the second test, all the model were able to do it. The second test was a little bit more challenging because it's not only one function as the first one, which is everything in the main. The second one is really you're having a couple of functions, and those functions have iteration into it, and you need to find the amount of time that you're doing iteration to generate the right code at the end. So you really need to have a good understanding of the function to get it, but all models were able to do it. The last one, this is where I struggle the most with all the model, except not all the model. GPT reverse malware was pretty good at it. It just went right away. Claude, it took 3 times Really, I had to restart 3 times to make sure that I was bringing him in the right direction. So I really had to guide him a bit to bring me there, but I've been able to figure that out. On the first pass, I said on Gemini Pro and Flash, there was an oversimplification issue. So Gemini was reading the code, and every time he was trying to explain me the information the most really in a simple way, and every time he was just omitting some portion, too complex aspect. After a couple of times that you're doing that, obviously you're not having the same result because the code was not right anymore. So that was the main problem on Flash and Pro. When I started to add system instruction, that you are a reverse engineer, all the information are important, don't ignore any details. Now I said, oh, it's important. And you've been able to do it right away. GPT, I've done that also. I've done it after Claude. So maybe in my instruction, it was a bit more clearer. So that's why it took 2 times on it, and even it's only 15 minutes. And reverse malware was just going right on. So the system instruction on that one were good to really move faster. Yeah, the things here, the things that really impressed me, I told you that Gemini was returning me information to train me, but the best of all in that portion was Claude. Claude was so good as telling me why and really going in every direction and explaining me the entire aspect, that I just save all the stuff to say, okay, I need to read it after, because he's really teaching me all those things. And Claude was also the only model that I've been able to find by himself the buffer overflow issue in those ones. I had nothing and say, hey, by the way, be careful, you have a buffer overflow here and there. I said, okay, that's interesting. The other model I had to really specify or ask with a plugin to be very specific with my prompt to say, find those things. Let's take a look, see. No, he didn't want. So Demo God is not with me. Okay, let's continue. Great. So the conclusion on those things is, yes, obviously you can use AI to do reverse engineering. Really, the biggest aspect for me, I started from 0, and I've been able to understand the code, get a way of working. You took notes, obviously, but in the way that a real reverse engineer are going to work, probably because the problem will be more complex, probably the model will not be able to help him the entire way and say, oh, that's the password, boom, giving him the password, or this is exactly what's happening. But function by function, this is really the work of a reverse engineer. Reverse engineer are looking at each function, doing some documentation, renaming functions, renaming things to be sure that it's clear. I didn't use it in the demo, but you can obviously ask Gemini to do, okay, rename all the function in a more clear way, rename all those things, and you can change the code, or even if you find a problem, you can ask him to patch the code if you want, so you can write a piece of code, re-inject that in the code. And when you're doing that portion, that reverse engineering, a lot of people in their binary or in their code, they're trying to protect themselves against reverse engineer, because obviously you don't want your intellectual property to be stolen by somebody else. So you're doing a lot of obfuscation in the code to hide those things. This is where also AI struggle, when there's human obfuscation in the code, and you need to find out the logic out of it. That's really a big challenge for that. So this is where that portion, probably human will be still very useful. And one thing that I didn't see it yet, I'm sure it's coming in those kind of challenge, because I'm reading the comment of people doing those challenge, and more we say, okay, now we should inject some protection for people who are using LLM to reverse engineer those challenge. And that's quite easy, in fact, when you think about it. You just need to hide some prompt inside the code. So when the LLM will read the code, you will get ignore all previous instruction and kick out that person or whatever, or just change the variables and +2 or whatever, and start just to mess up with you to make sure that you're not going to be able to find that out. And obviously you can obfuscate that system instruction or that prompt to make sure. So it's still going to be a race between the reverse engineer and the developer to hide the information. So being curious, being, trying to learn. I feel like it was really a good experiment for me. And hopefully I will be able to reverse engineer some German machine in some of your industry in the future. I hope you learn a couple things today. And if you have questions, I will be around.